Awesome. So, welcome to Developer Officers Session 8. Today we have Gevulot, the partner of ZeroG, and we have Norbert, who is the protocol engineer at Gevulot. He was previously participated in Ethereum Protocol Fellowship, researching prover selection and incentive mechanisms. He has also prepared a network design proposal for Aura Protocol as a research game. So, welcome to this Developer Officers, Norbert and Gevulot.
Thank you very much. Yes, just a little bit of thank you very much for having us here. A little bit of about me. I'm working as a protocol researcher at Gevulot, and we are really happy to be participating in the office hours as a partner of OG Labs.
Thank you. So, if you could just give a brief introduction about what is Gevulot and what problem you are solving.
Thanks a lot. So, basically, allow me please to give a tiny bit of background about the founders of Gevulot and like why Gevulot was brought to life. So basically, there are two co-founders from Finland, Teemu and Thomas. Teemu has a huge background in the blockchain space. He founded Equilibrium Labs, building core infrastructure with a whole bunch of projects in the ZK space like Starknet, Alio, ZkSync, Zcash, etc. And since ZK proving is a compute-heavy task, Timo and Thomas were wondering if there was a way to avoid 2-3 centralized entities to become dominant in this space as well, like it happened in Web 2. And this is why they started building Gevulot. And then I joined the team in January as they started to expand. So with Gevulot, we are building the ZkCloud, the first universal proving infrastructure. It supports any proof system at the fraction of the usual proving costs out there today. It's performant, decentralized, cheap. So in a nutshell, that's what we are building, but going a little bit deeper. So basically, there are three main things we are focusing on. We are generating ZK and validity proofs. It's mainly validity proofs for now. So we are doing proving, we are doing verification, and we are also working on different types of customization options to bring in TEEs, to bring in FPGAs or ASICs or this type of exotic hardware as they become available, and to allow a high level of customization for the very different use cases where ZK proofs or validity proofs would be needed.
Awesome. Thank you so much for that complete story journey from the start to the end. So, just was curious regarding your contribution to Aura Protocol and just a little bit more about. Just want to know more about your role at Gevulot and regarding Oracle, because I was a scholar at Aura Protocol prior to when I joined ZeroG as a dev. So I was a scholar there and I contributed to the ZKML part and after that to the OAO. So just was curious regarding that.
Yeah, actually, it was a research grant that I received from Aura Protocol late last year, and that was mostly about designing the mechanism or like preparing a proposal for network design for the ZK Oracle network. Currently, I think the main focus of Aura, as far as I know, is more the on-chain AI Oracle direction, and the ZK Oracle network is a little bit in the background. On the other hand, back late last year, early this year, basically there was a need for an entire network design. So how the ZK Oracle nodes would be working together with the prover nodes generating the proofs, how basically the entire economics and all the different aspects of the network design would look like. So that's what I've been working on with Swade and a couple other members of the team. And then actually it was closely related to the research project I've done with two other fellows in the Ethereum Protocol Fellowship last year. We've been mainly focusing on prover mechanisms, also particularly workload allocation mechanisms in prover networks and incentive mechanisms. And then we also prepared the proposal for STAC's decentralized prover coordination. They have been building in the open, and there was this request for proposals, an RFP issued for decentralized proving, and we prepared a proposal for that. That's where actually we met Timo as well. He saw our proposal, the founder of Gevulot, Timo, he saw our proposal, and we started chatting, and finally two of us ended up working in Gevulot. So yeah, that's a little bit of my personal journey.
Thank you so much for the introduction, because I also closely work with Suede as I was a scholar at Oro Protocol. And I was initially working on the ZK Oracle, and I was contributing to the ecosystem as a scholar. But I was there in the phase when they migrated from concentrated more on the OAO part compared to the ZK Oracle. So I also worked on the OAO. So that's a great background that you shared with us. Thank you so much. So next, to just continue on more with it, like, you would like to know more about the exact network details. For example, as per what I understand, the network design, it's like an innovative dual node architecture and a simple consensus mechanism enabled a centralized equivalent performing liveliness and availability guarantees. So, like, could you please just break down all the terms that I just mentioned, like, and you could just explain in simpler terms how the network works?
Yes, of course. Thanks a lot. Great question. So basically, in a nutshell, I would say we are building a programmable permissionless blockchain that allows any arbitrary proof system to be deployed as a program on Gevulot, and then by just sending JSON RPC requests, you can have proofs generated, have them verified, and then download them from the network. So there are basically two types of programs that can be run on Gevulot. These are prover programs and verifier programs. I think I'll talk about it a little bit later, but basically anything that can be compiled into an ELF binary can pretty easily be deployed on Gevulot. So prover and verifier programs come together. We need both because when a user deploys their own prover program and then starts sending requests to the network, we need to also have the verifier program internally to verify the proof, so that we know that our prover nodes have done the job properly, and they are and they can be they can receive the rewards for the valid proof that they have put out. And through this, basically, we already touch upon some of the network actors. So basically, as I mentioned, we have an underlying blockchain that's a very lightweight blockchain, Cosmos SDK based. Basically, blocks in Gevulot include transactions and proofs. There is no smart contract state. There is basically no re-execution. So we are purely optimizing and focusing on ZK proving and verification. And for this, actually, there are two main reasons why we need a distinct blockchain. First, it's useful because this way we can basically do a fair distribution of workloads and rewards in our network. But also we need that because if we build on Ethereum, if we build on an L2, if we build on any other network, then we would inherit actually the underlying economics of those networks as well. So it somehow ties your hands and limits the flexibility you can do when designing economics. And this is something super important for us because we really want to make proof generation cheap. Currently, one of the main bottlenecks in the industry is that proof generation is still pretty expensive. It is because most of the industry currently is actually using AWS or GCP, like these traditional cloud providers. And if we continue doing that, it's never going to be really cheap. And also, there could be much more optimized hardware setups than those found there. So basically, this is why we needed the underlying blockchain. And for that reason, we have validators and provers. So this is basically the dual node architecture you mentioned. We have two types of nodes in the network, and these are validators and prover nodes. Validators, basically, as usual, they process transactions, they broadcast workloads to the provers, they form consensus on block content and replicated state. There is a randomly selected leader for every single block that orders the transactions and proves into blocks. We are going to have a block time of about 1 second or slightly below. That's important for us because we don't want to put additional delay on the requests because of the blockchain and the underlying consensus. So we are going to have a super low, like 1 second or sub-second block time. And there are traditional block rewards and traditional fees related to the validators and like submitting a transaction. On the other hand, the other actor in the network, the prover nodes, the main task for them is to generate proofs. Again, we randomly select provers. That's one of the main differences, basically, to many other workload allocation mechanisms. There are auction-based or order book-based mechanisms. There are others that use proof racing, for example. We chose randomness because this is the least susceptible to centralization, basically, and one of the most neutral, basically the most neutral way to distribute workloads. I'm happy to go into details regarding this later on because it actually impacts the level of decentralization, or like rather from the other side, the centralization risks a network is facing is basically dependent highly on the workload allocation mechanism. So we've got these prover nodes randomly selected. They generate the proof, they submit back to the network, and the user can already make use of the proof and have it settled or verified wherever they want as soon as the proof is available. But we are also doing verification internally. And prover nodes are also selected. A subset of our prover nodes are selected to do the verification. Obviously, no one can do the verification for the proofs that they generated themselves. And basically, we have, regarding the guarantees or the redundancy, etc., you mentioned. So we offer customizable redundancy if you want multiple nodes to be working on your request initially, then you can submit it like that as well. Mechanism in place which ensures that if the prover node initially selected randomly to process the job does not deliver the proof, then the fallback mechanism kicks in. The user doesn't need to do steps or no further action needed at their end. Another randomly selected node will be picking up the job and will make sure that the user gets delivered the proof. So basically, regarding the like execution guarantees and liveness guarantees built into the protocol. On the other hand, we also have some economic guarantees. Both the validators and the provers will be staked, so there is some economic security there as well. Actually, pretty strong economic security there as well. And we are also going to do capacity verification for our prover nodes. So we want to make sure prover set, they are available and capable of generating proofs for our users constantly. And for that, there will be an initial verification, like proof of work type of tasks assigned to the newly joining prover nodes. And also random periodic verification will happen for the nodes so that we are sure they are available and capable. And obviously, I can go into details regarding that later on as well. We'll have pretty powerful machines, and the prover nodes joining will need to meet those minimum hardware requirements to make sure that we can serve very compute heavy use cases as well.
Got it. Thank you so much for the detailed explanation. So I was just curious, like you are able to achieve that block timing because of the uniqueness of your network. Like what exactly is the infrastructure that you have planned underneath? So I was just curious on that part. And the next thing is regarding the validators and provers, like how will the participation be and how can one participate even like from the community, like if anyone is interested, like what is the validity or like the criteria that you mentioned in order for a person to join as a validator or prover in your network?
So basically, we have a Comet BFT based consensus and a Cosmos SDK based chain underneath. As I mentioned, very lightweight. We don't host smart contract state, etc. And so that's on the blockchain front or the underlying network front. And regarding the validator nodes or prover nodes and how people can join or what are the eligibility criteria. So basically, there is going to be permissionless participation, obviously. The thing is, currently, so we are looking to launch our mainnet basically very late this year, early next year. The current DevNet, and I'm stepping back 2 steps actually, our current DevNet is actually, it has the full proving pipeline up and running since March. We've generated about 2 million proofs, but the initial DevNet did not have the economics and the underlying blockchain built out yet. And in between these two, the mainnet coming late this year, early next year, the permissionless decentralized ZkCloud, and the currently running DevNet, we have Firestarter, which is a permissioned version basically of the ZkCloud. It has already the underlying blockchain. It has economics, and it's a scalable, production-ready network, scalable to even hundreds or thousands of nodes if need be, depending on the demand. And this is coming in a couple of weeks' time, still in September. And users can already participate as a prover node, either by joining themselves with their own hardware or through renting some hardware from Gevulot, because we also started to build some size of our own cluster to make sure we have sufficient backups as well in the network from the initial phases onwards as well. And we offer a GPU node rental in case someone wants to join through that. And for that, there are some incentives related. If anyone's interested, then in our Telegram channel, we can provide further details on that. And feel free to get in touch with me as well. So basically, regarding the participation in the permissionless network at the coming at the end of this year, it's basically providing the necessary amount of stake and then having the proper amount of hardware resources in terms of CPU, in terms of GPU, etc. Basically, these are the criteria. The participation will be permissionless. We still haven't decided on the exact amount of, for example, stake needed, etc. So that's something I cannot go into further details in. But yes, so basically these are the details. Just one last thing. So the participation will be permissionless both for prover nodes and validator nodes. Currently, our Firestarter, coming in a couple of weeks, It's permissioned because we are running the validators in this first phase of our network. But as a prover node, basically anyone can already express their interest and join the network.
Thank you for those details. We'll definitely be sharing the Telegram channel and your contact in the community chat after this. So if anyone's interested to participate in the network, so feel free to ask Norbert regarding that. So thank you for providing insight on the network, the infrastructure, and the basic details regarding how it's being validated. So just on a more like in an example side or consumer product side, what do you encourage developers to build on? So you have a mission or like what do you encourage developers to build on? And you have any example use case that can help break down the complexity of understanding the whole process? So that would be great for the audience to have a better clarity on the total network and its usage.
Mm-hmm. Sure. Actually, I can basically talk a little bit about deploying a prover program on Gevulot and then how a proof request, like how the life cycle of a proof request looks like. So yeah, let's start off with use cases first. So basically, we are building a platform where anyone who needs ZK proofs, they can bring their own prover program, whatever language it is written on, whatever underlying DSL or proof system it is based on. They can take their prover, basically compile it in a way that it's compatible with Gevulot, and then deploy it in our network. These provers can be ZK EVMs of current L2s out there. It could be L1s like ZK L1s. It could be ZK coprocessors, or even you mentioned ZKML. So and ZK bridges, any type of ZK app that needs some kind of verifiable or provable computation. So basically, the way it works is that the prover program and the verifier program needs to be deployed on Gevulot as a first step. And then, as soon as you have that, both these programs will have a hash ID. And then you can start sending requests through a JSON RPC API, referencing the hash ID of those programs, and then sending also the inputs. So if we take the example of, let's say, a validity rollup, like, I don't know, scroll, linear, or the Polygon ZK EVM, as soon as these teams have deployed their own prover programs on Gevulot, their sequencers, let's imagine that they have decentralized sequencing, then anyone who is acting as a sequencer in these networks could start sending requests to Gevulot. So when a request comes into our network, then basically the receiving node that receives the transaction for the proof request would add that transaction to the mempool to be included in the next block. And once the transaction has been included in the next block and finalized, it is randomly allocated to a prover node. The prover node completes the workload and sends the proof back to the mempool. As soon as the proof is already available, it can be downloaded by the user, and they don't need to wait for our internal verification at all. They can take the proof, download it, and have it verified or settled wherever they want. If they accept the verification and the security, or like behind Gevulot, then they can also basically go with the verification that we provide, because that's going to be also obviously public, the results of the verification. So as soon as the proof has been generated, it gets included in a block again. It becomes available for verification, and a randomly selected subset of prover nodes that participate in the verification of the proof, they will vote on its validity. And once all of these provers have verified the proof, then the leader includes the result of the verification as well in the next block. And then basically the request reaches finality on Gevulot, and the rewards are distributed to the provers. So this is kind of how the whole end-to-end process looks. So deploying the prover program and the verifier program first, and then sending requests, referencing those programs, the hashes of those programs with the inputs, and the randomly selected prover node in our network would take the program, take the input, execute it, generate the proof, and make it available for the user. Maybe one more thing I'd mention at this point is that we are working, like, even though we are building a platform where we are focusing on making it super easy for anyone to come in and deploy their own prover programs and start generating proofs very cheap and on a performant network, we are also pre-deploying like well-known provers. For example, the Polygon ZK EVM, or Tyco's Ryko prover, or Starknet Stone. These are things that are already deployed in our network. We are working on different ZK VMs as well, RISC-0, SP1. Actually, last week there was this prover contest of Aztec, so we basically participated there as well. And actually, this was a contest to start involving external parties to do proving for Aztec's initial permissioned network that was spun up to test outsourced proving. And so basically we have Aztec's Barattenberg prover also deployed on Gevulot. We did a custom integration to our network, and we won that category in the contest. And also we participated in the general prover track where we tied with 3 other teams, but we had the lowest average proving time. So we were the fastest among the 4 teams that were able to generate each and every proof. So in that sense, basically, we ended up on top for these tracks. And that's a very good kind of sign of the network being live, being capable of generating proofs, and being stable. So at this point, I don't know, let me ask you, Gathin, shall I go into a little bit more details on the DevNet, on the registration, on like prover verifier integration, or shall we go in a different direction?
No, that's actually great. That was my actual next question. So it would be great if you could just continue on with that.
Amazing. Thanks a lot. So basically, currently, as I mentioned, we have a DevNet running. It's a permissioned network. So for now, you need to register a key and have it whitelisted. The key registration is super easy. I'd suggest you guys to go to docs.gevulot.com. We have very detailed information on the generation and the registration of the key. It's super fast and super easy. And basically, our DevNet, just as a general information, our DevNet is currently run by a permissioned set of node operators who are taking care of the costs of the prover nodes. So basically, it's free for any user. You can have proofs generated and verified free for any prover already. We've generated about 2 million proofs since late March, when our DevNet was running. We have about 390 different programs deployed on Gevulot. Some of these have been deployed by us. As I mentioned, some large, well-known prover programs, while others have been deployed by the users who are doing benchmarking on Gevulot, who are using it to generate proofs even now. We have a couple of VMs, ZK VMs already deployed there, like the Eigen ZK VM also, for example. So basically, it has the full proving pipeline, and you can already, after this office hour, generate a key, register, and then start using the network. Regarding prover integration, we are making it like one of our main goals, obviously, is to give a good experience for developers and to make it easy to integrate with Gevulot. Our current network is slightly different from what's coming in Firestarter in a couple of weeks' time. But we are making a whole bunch of simplifications for Firestarter. In the DevNet currently, we are using basically Nanos VMs to run the prover and verifier programs. The Nanos unikernel, it provides a very lightweight operating system, super fast, like milliseconds to spin up. And this is why the DevNet was implemented with this runtime environment. So regarding the integration process, basically, the provers that can be compiled into a Linux binary, like are the programs that are compatible with x86 64 architecture and communicate via the gRPC protocol, those can be very easily deployed on Gevulot. We've built a shim library, a helper library in Rust with C bindings to help and to make the integration simpler. Basically, if you have a Rust program, for example, and want to run it on Gevulot, then want to deploy it on Gevulot, there are basically two small modifications needed: a callback function for running the tasks, and then a delegation to the shim, a new main function to delegate control to this shim library, which interacts with the network. We've got some sample codes also under the integration section of our docs at docs.gevulot.com. Then there's a second part which is related to packaging. So as I mentioned, the DevNet runs programs in the Nanos VMs. The users need to create a manifest file that contains the configuration data on how the system should run these programs. We also have some examples in our docs for the manifest file. And then there is a certain tool called Ops for working with Nanos, and the packaging is currently on our DevNet happening with that. So you need to compile your program into this Linux x86 binary, and then build the program image using this tool called Ops to create a bootable image. For that also, we have detailed instructions in our docs. And I think with code snippets, examples, etc., I think that would be probably the easiest to look at if developers are interested in starting working with Gevulot. And then the final deployment, basically, so as soon as you have a key registered, you have already the CLI installed, then you calculate the hash for your programs to make sure, to ensure integrity. And then you need to upload the programs into an HTTP server, a publicly available or publicly reachable HTTP server, and then deploy the programs through the CLI. It's again very straightforward. We have code snippets, we have examples and comments in the docs. So there are three main sections: integration, packaging, and deployment, which you find in the docs related to our DevNet. And as I mentioned, we are making some simplifications in Firestarter. So instead of Nanos, we are transitioning to the Linux VM and to using containers. So it's going to be even much simpler to work with Gevulot. But we are going to share more on that as we get closer to the launch late September.
Thank you so much, Norbert. It was more than detail and it was very clear. So we can go through the docs, but it would be great if a person who already has a hands-on experience on it, giving words from there. It's really great. Thank you so much. So just to continue with, we'll just conclude the session by you telling the integration with Zero G and how our potential partnership could have a greater impact later, and also how can we participate, or is there any events going on or is there anything that we people can contribute in open source to Gevulot's building? So just throw some light on it so we can just conclude the session with that.
Awesome. Thank you very much for that. Yeah, so basically with OG Labs, we are, so what is our partnership or our collaboration is going to be based on the processes that you guys have regarding proof of random access and data availability sampling. So basically outsourcing those proofs, making proof generation more efficient, driving down the costs significantly related to those proofs. That's something where Gevulot comes in, and where I think the largest part of our collaboration lies. So we can help any validator or participant in your network involved in the proof of random access and the data availability sampling processes that needs proofs to outsource this proof generation to Gevulot and make it super efficient. Regarding the some events or where to meet us or how to participate, we are going to. We've been attending some hackathons in Krakow and Montreal earlier, and we are going to have some such events later as well. However, actually, just next week we are going to be in Singapore and also hosting two small events. It's called ZK Morning Coffee on the 18th and the 19th. In case any one of you guys are in Singapore, we'd be happy to chat and meet you in real life there. You can register for the events in Luma. As I mentioned, we've got the docs with all the detailed description of our current developer side and related to the DevNet, and also the current network architecture, so the network design as well. And we've got the DevNet available for free proof generation for any proof system out there. And in a couple of weeks' time, we're going to have Firestarter, and developers and teams can start using it and interacting with it. In case you have any, and I'm addressing this to the whole community, in case you have any use case close to production or with higher and heavier compute needs for proof generation, get in touch with us and we'd be happy to chat, because Firestarter as a scalable network is actually built to be able to serve those use cases at the fraction of the current proving costs out there. Yes, I think these are the main things. And if you guys at OG Labs see any further potential for outsourcing proving, I don't know, I'm just throwing in ideas like aggregating proofs you are generating within your network, or related to verifiable AI, or in case there is any proofs to be generated there, we'd be happy to support you on any front regarding any additional proving need that may arise at OG Labs.
Thank you so much. I'll definitely consider it, and I'll have an internal discussion with the team on the requirements, and we'll get back to you on that. And see you in Singapore, because the whole team will be headed over there, and we also are hosting our happy hour at on 19th. So looking forward to meet you there too.
Amazing. I'm going to register for that. Thanks a lot for mentioning.
Awesome. I'll share you the link in a while. So thank you so much for the detailed explanation. And thank you, audience, for joining us to hear more on Gevulot. We'll be sharing the details soon. Jan, our community manager, will share all the details on the Discord channels. So just follow us and stay tuned for the 9th session next week. So thank you so much, Norbert, for making your time today. And thank you, Jan, for hosting us. Thank you, everyone.
Thank you very much for having me. Thank you.
Thank you so much, Norbert. Thank you.